Welcome to the Public Works Nerds Podcast.
Welcome to the Public Works Nerds Podcast. I'm Mark Culver, your host, and we are joined here today with Ross Bittner from the City of Edina, Minnesota, for those of you all over the world. A true public works nerd, Ross is. I've listened to Ross give some presentations on a variety of topics, including EV chargers in Edina, and your wealth of knowledge, your breadth of knowledge is pretty incredible, and I'm very impressed with that. And today we're going to really nerd out on one of your favorite topics, I'm sure, stormwater. But before we do that, let's talk a little bit about your career and how you got to where you are. Ross, you've been with Edina for about 11 years now. Did you come in as the engineering services manager?
I started with a different title.
Okay.
Held that for 3 years.
Okay. And then morphed into the engineering services manager. And then prior to that, you were with the City of Prior Lake as a water resources engineer, and that was 6 years.
Yep.
And then prior to that, our sponsor, Bolton and Mank, you are an alumni of Bolton and Mank. So you started your career here for about 3 years.
Yep.
So, maybe talk a little bit about that. I sense, obviously you were a water resources engineer with Prior Lake for 6 years, but how did you develop maybe that passion for water resources? Was it in that role or was it prior to that?
Yeah. I've often plumbed my depth to figure out where I really came up with the love of water. And from the very earliest moments of my childhood, I was, playing with the hose on the front step. I was digging the puddles in the driveway when it rained, exploring the creek up and down.
Were you timing the amount of time it took to infiltrate the water into the mud?
I wasn't that scientific about it at the time, but I was definitely creating a mental model of what water was about.
Yeah.
So yeah, it's an early love. Thanks for bestowing that honor of a true public works nerd.
Absolutely.
I appreciate that. I've really gone the water route.
So now that you're, before we dive into the topic today, which is a really innovative stormwater control system, maybe talk about now that you're like the engineering services manager and you deal with everything.
Right.
Engineering now with Edina. How does that feel? Like, I joke with people that I'm a recovering traffic engineer, and that was my background, was a traffic engineer with City Maple Grove, and then I went to Roseville, became the city engineer, and it was interesting because when I went to Roseville, like traffic was, it's always an issue, but it wasn't the big issue it was in Maple Grove. In Roseville, stormwater was the big issue in Roseville.
Yeah.
And I learned a lot about stormwater from that point, but maybe talk about that from what was your traffic and your stormwater,
right?
At Edina, moving into that larger, more vast role.
Sure. Yeah. So at my immediate prior experience at the City of Prior Lake, my boss at the time kind of just gave me the water quality utility and said, here's $700,000 a year that comes in. Let's figure out the best way to spend it. And so there was a little bit of that utility management practice and philosophy that I was building at the time. But I did come in with, the real love of the stormwater and the flooding and the clean water services that I was able to provide at my prior job. So 2012, made the leap to the City of Edina management role in my first. And it had a lot more to do with the information systems, GIS, all the permitting coming in, the water resources piece as well, and then sewer and the domestic water system. So I really had to expand my toolkit. So getting involved in all the professional associations. I've been a longtime attendee now of the American Waterworks Association and their conference in Duluth. So, just boning up and getting up to speed on all those other utilities. But I found that a lot of the passion that I had for water resources transitioned over to those other things fairly seamlessly. And a lot of the tough problems in water, they really connect us all. So it really gave me a leg up when it came to, talking the talk with the public and, best describing, the public purpose to some of these infrastructure systems that really do seem like magic to, people who only experience a small component or on a day that they're having at their worst and they're failing, because we have a huge storm event. So We had some formative experiences early in my time in our department in 2014 with some really big flood events and basement backups on 9 Mile Creek, and a tough day for the utility. Wow. So that really weaved in a lot of kind of the risk type of ethic that I'm going to be talking about with the project that we're adaptive level control and real time controls.
Yeah, which is a great segue into our topic today. And like I said, we really are going to nerd out on stormwater here. And why don't you talk about the end result of this project was this water level control system for an existing stormwater system, right?
Yeah.
And which I think is wonderful. And in my position, it's all as a smart cities director of smart cities initiatives here at Bolton Mank. That's what I'm looking for, is how do we apply technology to make our operations, more relevant and more efficient, and also responsive to resiliency,
right?
As we're in this changing climate that we're in right now. But how did you get here? Like, kind of talk through the process of what the problems were, identifying the risks, and kind of coming up with this crazy innovative solution.
Right. Yeah, I think, the story, as we often tell it, goes back to 2018 when we updated our surface water management plan. And that was the first time that we actually took tables of flood risk data for all the different sub-watersheds in this first ring suburb and visualized them. So as you put in front of your council and decision makers and your public the actual peak flood risk of the whole first ring suburb, built in 1940s infrastructure, it looks stark and it looks like a system in failure. So I've done talks at the Water Resources Conference and others about that system in failure idea, and it really goes back to first ring suburbs built with the assumption that climate wasn't changing, that the 100-year event now and in our record is the 100-year event of the future. And I think that 2018 moment for Edina at least was looking at that new Atlas 14, not a future climate scenario, but just a more current past climate scenario, right, was failing out big portions of the system. So we've got 1,000 or more homes in Edina that are potentially at risk of flooding or flood exposure during the 100-year. That was a shock. So I think that was really the kind of the baseline that got us to really trying to pull out all the stops in some of these big neighborhood recons and these flood infrastructure projects that we're envisioning now.
All right. So then, what did you do with that information?
Right. So we knew that in our Morningside neighborhood, the far northeast corner of the city, one of the oldest neighborhoods in the city of Edina, we were going to be investing significant resources in 2 major street reconstruction projects over the course of the next 5 to 10 years. This is back in 2018. This is a project now that was done in 2022 and 2023, the neighborhoods. So we knew we had about a 5-year window to make the right studies to really put the problem in focus, so that when we did all those streets, we wouldn't miss that basically once in a generation opportunity for that most flood affected area. So that's kind of queuing up our Morningside flood infrastructure project. We started envisioning what that might look like. We did a variety of different engineering feasibility studies, figuring out how to, store the water, how to off-peak the water, where to store it in the watershed, where to take the best, how can we get the most value out of the dollar. And we knew that the current method of, just choosing a design storm and then trying to figure out a design that was going to get everyone out of the flood just wasn't going to work. And that was what the council tasked us with first, was develop a flood risk reduction strategy. We know that the current tool set isn't working. So we actually met for a year with a task force, the Flood Risk Reduction Task Force, ahead of a major amendment to that plan to say, how are we going to organize this work? How are we going to really put it in focus so that we know that the investments are the right ones to make and that they're acceptable to the public? And that where is this in terms of our priorities? And the flood risk reduction task force really kind of taught us what flooding meant to the public. And as we first started talking, there was a real gap between the engineers and the technical speak and the understanding of the service level of the public. So we sat around the table with 10 members of the public, and we just kind of appreciated the gap between public expectations and what we knew we were able to provide. And they were the ones who really challenged us to, how do you reduce the flood exposure to properties citywide through everything you do? And we have a four-pronged strategy now for, really doing that. And this infrastructure focus that we'll focus on today is really one part of that strategy. But the other parts are, emergency management, the regulatory system and the regulatory control, making sure that, people know what flood risk or flood exposure they have so they can move their structures up when that time comes. Yep. And then just the outreach engagement around it. This needs to have a community capacity to it to really address it because it's such a big, intractable problem. It's what adaptation for climate futures is about. So we really wanted to do it, in partnership with the community.
Yeah. So with the Morningside project that you were talking about, the Morningside neighborhood, what specific elements did you do as a part of that project?
Yeah, so it started with a really intense engagement where we knew, approximate outlines of what we were going to do. We didn't know how big, so we were basically saying, here's like small, medium, and large impact to the goal and impact to the neighborhood. What does it mean to, reduce the flood exposure to 25% of the homes? What does it mean to reduce it for 50% of the homes? And we took that to the public. We really engaged using the IAP2 model, public participation, only going to the public where we really needed their feedback. And this project was basically considering the removal of a 6-acre portion of the Weber Woods area. So a really big, consequential, you can't go unnoticed. It's not just a pipe size increase underground. So we knew we were getting into something big that the public needed to understand. And that's really, the strategy to it, which was create more flood storage, use it more effectively, because we knew we couldn't dig a new pipe, a bigger pipe, all the way downstream to Bidemakaska and through Minneapolis. That was just not on the menu.
Right.
So it was like, how do you do that internal risk transfer in your own neighborhoods? So bring it down to the low areas, create more storage. I like to say the recipe for this flood project was 1 part risk transfer internal to the city, 2 parts flood storage. You want to make sure that those areas that are low, that see the most potential exposure to floods, have durable benefits there, because over time, that's where the climate change future kind of eats away at the benefits down in those low areas.
So in these areas, these flood prone areas, had they actually seen flooding?
Yeah. And interfacing with the neighborhood, it was kind of interesting to see the mixed remembrance of those, because this area did have some significant flooding in the 1987 Stormer record. A lot of homes sold in 1988. So
that's a coincidence.
Yeah. So, but there was definitely some people who were around and remembered the trauma of, having to help their neighbors, remove things from the basement. Luckily, no lives lost in this neighborhood, but that storm did have lives lost with people who were, trying to pump out their basement and had, foundation cave-ins. So, yeah, it was a 87 storm event. That was a big one in the flood record. But yeah, there was some remembrance of it. Other people, I've lived here for 11 years. I've never seen a flood. So, getting everyone, in touch with the data and the science that we were predicting, it was a good gut check and getting on the same wavelength about, what risks we think we're taking and what risks we're willing to take in that future after the build condition. You needed to get a lot of people up to speed, because you don't need to move a 6-acre urban forest just willy-nilly.
Right.
It has to be a really valid public purpose.
Right. Well, kudos to you in being able to communicate that and building in that resilience for those future storms, which we no doubt will have. So then how did that, how did that, how did you, 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 how d these projects, these future-looking projects, how did that maybe evolve into, real-time control?
Sure. Yeah. Well, there's one graph in there that I'll kind of describe. It's about marginal benefit, marginal utility. So as you're starting to build a pond or conceptualize, building a pond deeper, you already have a low area. And you have to figure out, where is your effective volume, the current outlet elevation up to the current peak elevation. And as you expand that pond more and more in concept, the actual elevation starts coming down and your window of opportunity starts going down. So from like 880 or 860 to 868, you have an 8-foot window of opportunity. And the further you get out into areas that aren't low, you have to take a whole bunch of overburden off.
Oh, yeah.
So, the cost to create an acre foot of flood storage of 43,560 cubic feet of earth is, the cost to truck that out and to put it somewhere else and to, build a hill somewhere where they need it. So it's generally just the cost of trucking and earthwork. But, as you start to envision that pond now, you can actually make that effective area bigger by lowering the water elevation where you can. This is not something you could do with a natural water body. You'd be draining a wetland, right?
Right.
Like these were stormwater ponds.
Yeah, these are traditional NERP ponds.
Yep, right.
Yeah, built in the 80s.
Yeah.
Probably.
And you normally do that through creating a pipe down to the next water body at a lower elevation. Yep. Like I said, that was off the table. So for us, that meant the creation of a lift station to artificially keep that water elevation lower. So then as you start to add on, that margin, you suddenly get a whole new tranche of acre foot storage or, flood storage for a whole new price elevation. It's the total storage you can create times the cost of, or divided by the cost of the lift station. So now if you have a lift station and you've got a pond, now it's just a matter of, can you operate that lift station, or that maybe it's a valve and a articulated valve differently, to even activate more of what we normally call dead storage. So it's the activation of dead storage is the adaptive level control. We do that with a real-time control system, creation of an algorithm.
So, just kind of for maybe the lesser nerds out there, talk about the difference between like the normal operation of a lift station versus the real-time, a real-time control of it.
Yeah. So what is the difference between, the creation and the...
Like a lift station, how it would normally operate versus operating it in a real-time, real-time environment.
Here's the best way to think about it. Imagine you were 24 hours from another 1987 style storm event, and you were asked the question, is there anything we can do to prepare for the flood that we know is coming? What would you do right then with that lift station? You might run the numbers. You might say, we expect there's to be 100 acre feet coming our way in this sub-watershed. We should lower this as much as we practically can in the next 24 hours. Or maybe it's a lesser storm and it's only half that size. And you might say, we'd still lower it that much. Or an even lesser storm, we might only lower it half the way. So that type of, putting yourself in that future place is what the creation of an algorithm for real-time control is all about. You're essentially saying, here's where I want to see the benefits. Here are the trade-offs I'm willing to make. Here are the trade-offs I'm not willing to make. And you have to do it with a lot of people in the room, because creating this drawdown for flood storage has other potential trade-offs for clean water, for the groundwater, the water table. So you want to make sure you're well aligned.
Also, where you're sending that water downstream.
Exactly. Yeah. Downstream parties, the downstream watershed. When we got into the actual design of this, that's where, this was really a square peg for the regulatory round hole. We know this is not something that we have regulation for right now. So we had to start taking it to like a regulatory principles level to say, what are we trying to accomplish with some of those regulations? Are we still meeting the intent? Regulations might pick 3 storms and 3 specific antecedent moisture conditions, and they have assumptions built in. But with a real-time control, you've got potential to run infinite models based on infinite variables. You're only going to choose a handful of variables: National Weather Service forecast data, pond level data, other water level data if you have it networked. But you have to essentially put yourself in the condition of monitoring not just 3 storms, or not just demonstrating performance on 3 storms, but demonstrating performance on a whole portfolio of storms.
Yeah.
And it's not as easy as you think, Mark, because sometimes as soon as you develop that algorithm, you could develop another algorithm or another storm that would be the perfect antidote to that algorithm, right? So it's a matter of using that risk, the best, the trade-offs we're willing to make, the best guess, and the risk piece has to be a strong part of the conversation, because that storm you could develop could be even worse outcome, right? Right. Based on the algorithm you created. So,
well, and that's part of the problem with our storms these days, is that they're highly unpredictable,
right?
And they're also very highly localized. So you could be planning for a storm that's coming, and it might completely miss you.
Exactly. So
and they might get 6 inches 2 miles north of you.
Right.
But yeah, that's the challenge in this, and even a real world environment is how accurate those predictions are.
Yeah. So we call those false positives or false negatives. We predicted a storm and it didn't come. We didn't predict a storm and a storm came. So you have to start getting comfortable and getting your regulators and the operators all comfortable with this idea of, this is a piece of the system that's doing its best. On average, it's going to be 95%, and it's going to be adding a lot of value, but it's not always going to be. So, how do you get comfortable with that risk metric? We know that through that flood risk reduction task force, it's of high value to our residents.
Yeah.
But when you try to put it through the current regulatory paradigm, it has some challenges. So I think that's our next steps, is getting into that governance and the regulatory side of it.
Yeah, which will be some interesting conversations, especially as more communities start doing this.
Right.
So for this particular project, and it's interesting, you've got quite a bit of research on this, and you had a group of students do a capstone project on it and such. So it's interesting that I think the system's only been on for a few months.
That's right. Yep.
But you've already got a lot of data and analysis on it and such, which is really interesting. But so as I understand it, you took 2 ponds in your system and you added some. Did you have to add the lift stations to them? Did you have to add the pumps to the ponds as a part of this?
Yep. So we did 2 ponds for flood storage. Only one of the ponds, Weber Pond, was outfitted with a lift station and real-time controls.
Okay. And so then you added a lift station to the other one. And are these, lift stations can be, small pumps. They can be huge pumps. They can, run 6 hours, 24 hours a day. They can run 2 hours a week.
Right.
So in this case, like, what level did you put in?
Sure.
And what kind of infrastructure did you put in for this?
Yeah, let me give you a scale for the watershed. It's less than 200 acres of drainage area. We were creating about, let's say, 70 to 100 acre feet of new flood storage. Mm-hmm. And the system itself has about 20 of those acres that are activated, that are normally part of the dead storage and that can pump down. The pump system here is a dual 10 cubic foot per second pump that can, dewater in about, let's say, 30 hours. So it's looking out at maybe a 5-day forecast. It might only be making decisions at the day 3 with a 70% probability. So, it's pulling forecast data every 15 minutes, and it's rerunning that decision-making algorithm to say, all right, is it a pump or a no pump? So yeah, it's significant size. The whole project was about $12.5 million of design and capital. A lot of that went into the earthwork, $500,000 or so into the lift station, and then just a tiny fraction, that last increment, the 20 acres that we got from the flood storage was, less than $100,000. So it was interesting how every increment of flood storage we built with the earthwork, with the pump, with the adaptive load control came cheaper and cheaper than the past increment.
Yeah, that is interesting.
Yeah, that's not something I've ever seen before, where as you build it bigger, it gets more effective.
Right. Hey everyone, I just want to take a quick moment to thank our sponsor, Bolton & Mink, who is producing and editing our podcasts.
At Bolton & Mink, we believe all people should live in a safe, sustainable, and beautiful community. We promise every client two things. We'll work hard for you, and we'll do a good job. We take a personal interest in the work being done around us. And at the end of the day, we're real people offering real solutions.
So, and then imagine you are communicating with these lift stations. Is this independent of your SCADA system, or is it wrapped into your SCADA system?
Yeah, it's actually a mix of the two. So for simplicity and for security's sake, the lift station operates off of SCADA,
Yep.
Direct connect to fiber, and it only has one bit or two bits that it communicates with, and then bolted on the side of that lift station cabinet is an OptiRTC, there's the vendor name, their control system, which takes data from cellular. So they're communicating across, a fiber and a cellular, different communication paths, and then there's two wires that cross. One is from the lift station that says my pump is on or my pump is off, and one is from the Opti system that says override on or no action.
Okay.
So it's a 1 and a 0 and a 1 and a 0 on two lines attached.
Cool. Isolation's good from the SCADA system.
Yep.
We all know the struggles and challenges with the security of that system. What else do I want to ask about that, about the system itself? So it was relatively easy to retrofit the existing system for this. But talk maybe more about that Opti system and what is involved with that.
Sure. Yeah, so Opti is a vendor out of Massachusetts, and they've been up and running for a handful of years, or maybe a decade. We haven't found a lot of peers to their type of work in terms of creating the control systems and the algorithm creation, and a lot of that is their proprietary black box piece.
Yeah, and just as a reference, I know in Roseville we use that on a couple of underground systems that we were using for irrigation.
Sure.
And the similar concept, in advance of a predicted storm, we would pump out the underground system and make capacity for the new rainfall.
Yeah, and maybe primary purpose there was for clean water purposes, to make sure that you have the most availability of that storage to really do its clean water work. Right? Yeah. So these systems are, they're national now. But yeah, this was maybe a little bit different purpose for that real-time control to really dig down deep in the flood side. And yeah, it was a conversation between our designers who were putting together the pump system, our integration control people who were putting together the SCADA and the programming, the electrical systems, and the Opti vendor. And yeah, we got involved with a separate professional services contract with them to pay them for some of the design and coordination with our normal design team.
Mm-hmm.
And then during this startup period, there was a lot of work happening at the electrical controls, SCADA programming, and then just a couple of days where we're calling them on the phone and saying, all right, trigger the Opti system. Let's make sure that the signal is coming through. So yeah, it was pretty seamless in that respect in terms of implementation.
So I had a conversation with one of our stormwater experts here at Bolton Mink, and he brought up the point of, because and I am a stormwater rookie, all right, when it comes to this, but one of the questions I had is, so could you use this real-time control to maybe, just to start here, a lot of communities are faced with dealing with sediment in their ponds and having to remove that sediment to return the storage and treatment capabilities of those ponds. And so I thought, well, could we use this in lieu of having to dig out all of that sediment?
Sure.
And he said no, but that led to the conversation about water quality. And so, you kind of touched on it, that there's some maybe, depending on what that water level is, there could be some disadvantages to water quality, but there could be some advantages too.
Right.
So maybe, dig into that a little bit.
Yeah.
Let's nerd out about the water quality aspects of this.
Yeah, that's one of my first passions. So,
yeah.
Water quality in a stormwater pond has everything to do with settling of particulates. And then there's kind of an irreducible fraction in there that dissolved that we may or may not be able to target through some of the biological actions in the pond. But either way, the more time of residence you can create in that pond, the leading theory goes, the better you're going to do in terms of a water quality outcome. So for this project, we did consider that. We had an add-on study for clean water options as part of our regulatory follow-on. And we looked at what are the operating parameters now, putting yourself again on that day before the storm, maybe not a flood event, but maybe a smaller event, the typical 1-inch event. What could you do to improve the residence time of that system? So, and that includes for flood benefits as well. If we take a 10 acre foot volume storm in the pond and we move it forward in time, and deliver that water clean from the prior storm, or we wait and not pump down on our typical, but wait 3 days afterwards, you can see how many acre feet of flood volume or water quality treatment you moved on that hydrograph, either forward in time or backward in time, to create a lot more of the storage. So we ran typical P8 models. We said, all right, here's the potential for additional residence time, and it had an appreciable effect. Just through smarter operation for basically, just the cost of, doing the study and doing the knowledge work, you can now operate that thing for a small event. All right, let's do a little bit of a pull down, or let's do a long 3-day hold on the stormwater that did come. So yeah, benefits accrue on both sides, clean water and flood protection.
That's interesting. So from a phosphorus perspective, like how much more phosphorus do you think you can remove from your system if you're doing that control?
Yeah. So for this area and for the type of actuation that we had, it was not the majority of it. The bigger pond was the majority of it, but it was another 8 pounds of phosphorus, for example, just through smarter actions and pumping.
Yeah, that's huge. I mean, given all of the money that we're spending on iron enhanced filters and such, that's huge.
Yeah. Well, and the marginal cost of that additional pound of phosphorus per year for the next operation of this system was tiny. So it was the biggest no-brainer, the smartest thing we could have done, because it cost us basically nothing.
Right.
And now every time you learn something new about either the flood side or the clean water side, you can upgrade it. So think about your EVs that are coming out today. They say they're upgradable. So the product you buy today is different than the one you're going to have in the future. You expect it to maybe improve in value in some cases. We've got the same thing in our infrastructure now. We're going to be able to use our smarts on this 10 years from now and say, all right, we did a system upgrade. We've now got software version 1.2, and it's going to give us another 2 pounds of phosphorus. So yeah, the more we learn, the system can be upgraded real time.
Yeah, and that's and those upgrades are really just tweaking the algorithms and such, based on the experiences you've had and the data you've collected and such, right?
That's right. And that gets you back to that regulatory challenge too. What sort of regulatory process am I going to have to go through to now upgrade my infrastructure and recraft that algorithm?
Yeah.
Right? We got to make sure that all the things that were agreed upon on day one remain during the upgrade. And, someone's going to want to know, the downstream folks, the regulatory party is going to want to be assured that we're still getting that same performance and we haven't taken any other unacceptable trade-offs.
Yeah.
So a real challenge for the regulatory community coming up.
Oh, that's really interesting. So talk about the expansion of this system now that you've done it here in 2 ponds, you learned some lessons. Like how much do you expect you would pay? And maybe you started looking at this already, but the next pond that you want to outfit with this, how much do you think it's going to cost you to outfit that pond with a similar system?
Yeah, interesting question. I'll answer it 2 ways. One is, the cost might be $50,000 to $100,000, depending on, the software is pretty consistent, but the amount of plumbing you have to do might really change. If it was a really big system, you could be upwards of, $150,000, $200,000, depending on if you had to run pipe or whatever. So that's kind of a ballpark for the cost. But where we did it was on a stormwater pond, which was a much lower regulatory hurdle than if we were to plan to do this on a natural water body or maybe a public water that's more useless to the stormwater pond, or maybe it's just a straight up lake where you could see that same, 24 hours from now, there's a flood storm. The right thing to do might be let water out.
Right.
But now you're taking
Now you got lake home associations and
you're
regulatory authorities to deal with.
You're taking that challenge to the next level, and that's how kind of how we're thinking about it. We know that this is potentially one of the very high value things we can do for clean water and flood protection in the city. So what we're doing now is engaging partners, and we've got neighboring cities and watershed districts interested enough that we're going to be doing basically a watershed-wide study of where the opportunities are. And this is a project that's going to be taking about 18 months of design, conceptualization, and consensus building with neighboring parties and regulators, so that in 2025 or 2026 we can build another 3 to 5 implementations of this throughout the city. And we're going to be kind of leveling up that regulatory discussion we had from city district level to city DNR level to state, to city, state, local.
Yeah.
So yeah, we got a lot of activity and a lot of interest kind of in the area near Edina, and yeah, we're moving forward with future applications.
How many NERP style ponds do you have in Edina?
Yeah, first ring suburb, we don't have many at all. There's let's say less than 15 of those, and a lot of them are of a scale that it might not make sense to pay the $100,000 for an install on one of these things for just the less than an acre foot of storage of control you might have. That may be different for a fourth ring or third ring suburb, planning something new. But for us, we just don't see other NERP style opportunities. Our opportunities, well, maybe one, Centennial Lakes.
Okay.
Very high profile pond, one of the best known ponds in Minnesota. There's an opportunity, but that still is only, maybe 10 acre feet, 20 acre feet if we really articulate the flood storage volume. The bigger opportunities are on the lakes, the creeks, and the big wetlands.
Which gets into the regulatory items you were talking about. Do you see like an evolution of this technology or this system? Like what is the evolution of it beyond, actually just the pumps and that?
Yeah, I think the algorithm, there's a couple uncertainties packed into that, right? One is the creation of the algorithm in terms of how much runoff is generated for a given storm event. But then it also has the external party piece, which is the National Weather Service, or a proprietary forecast based off of National Weather Service data. So I think there's kind of that, we can get better at forecasting. We can get better at algorithm creation. So there's multiple points of improvement in the process. And then the cost to turn the crank on the implementation side, once we get a little bit more consensus on the regulatory side, we can even improve the performance and the value that we're able to provide, because we'll make it easier once the kind of the statewide consensus around these things develop.
Yeah.
And that's a challenge that, we're helping to add into, but I think we're maybe the ones that are waving the flag on like the opportunity. And that's why we're looking for partners to really get involved in the conversation, because permitting with a statewide agency from a local level just doesn't seem like a fruitful thing.
Right. And that's where the critical mass at some point, when you get more and more people or agencies that are interested in this, or maybe even doing this at some level, can help push that policy side of it too. Where do you see the risks with this system? Like if it's done wrong, and you touched on it a little bit, I think, with water quality, but like what are the risks in managing the system in the wrong way?
Yeah. Well, it's you're always going to make the decisions you have with the best information at the time, right? So there's always that informational risk. Did I not have the right information at the time? But there's also a little bit of a, expectations risk as well. With our current systems, if something clogs or, things didn't perform, are you really going to know, right? Yeah. That pond probably peaked higher because there was a clog in the system. Now with real-time controls, you are monitoring, every 5 minutes, the water elevations, and you can really pinpoint a failure or maybe an unexpected operation. So you're going to have data of a failure or maybe a reduction in performance on a storm that causes damage. Now, I always like to compare this current situation with the current, paradigm.
Yeah.
You don't have that same data on the clog or the whatever that happened or but so you don't have any opportunity to improve. You're going to have that perception risk of, all right, I know what had happened. I had data on it. It failed. Your fault. Right.
Right.
Where on the the other one is just, you don't have the data.
Right.
Act of nature. Right. So I think we always have to be, when we're talking these risk things, compare it to the current paradigm.
Yeah.
So I think that's a big reputational risk,
Yeah, that's a good point. Just because you didn't know it failed or you didn't have the data doesn't mean it didn't happen.
Yeah.
But now we just know and we can learn from it and do things better.
Yeah. The more sensors we have, the more that's going to be current and present.
Right. So maybe talk a little bit more about, and you touched on this in the neighborhood meetings and such, but and through the process with the surface water management plan and that. But now that this system is in place and you've got some of this data, what's been the reception from the public? Is there any backlash? I mean, are there any people that are still opposed to this for any reason?
Yeah. So when I bring it up to folks, they're seeing the new pond, they're seeing the nature space that we're creating here. It's going to get better every year with the prairie growing in and the trees blooming. So I think there's a lot of public support for the project in general. The adaptive load control piece of it is still just a little bit of like a aha moment for people when we describe that. And it also has this capability. We haven't really seen the false negative or false positive yet. And I think, keeping up with it, and the day that we pump this down for a big storm that doesn't come,
yep,
there might be a little bit of like, why is the pond so low? But we also took into consideration, that in the design. So we're doing good to really, vegetate those shorelines, make sure that we've got some good emergent, submergent plant varieties in the mix. So it's not going to look too out of place. So that's a low risk. The higher risk is the condition where you do not predict a storm. You get damage.
Yes.
And it should have. So I think, that's one that we know is out there. And we're going to want to be able to say, all right, here was the 15-minute by 15-minute data. And luckily, it's not just one decision it makes. It makes that decision as the National Weather Service forecast ebbs and flows. It's always using the most current information, and it's making that call every 15 minutes. So you kind of have an area under the curve. I was maybe a little less right during the early part of the storm, and I got more right later on in the storm. So I don't feel like it's going to be just a complete storm out of nowhere.
Right.
It'll just be a matter of, were we able to get the whole pump volume as the storm neared on that big storm.
And to that point, now that you've got this real-time data and you're monitoring the pond elevation, have you created, and maybe even separate from your SCADA system, have you created any dashboards or alerts or anything so that maybe you guys can take some action if something in the prediction model didn't go right?
Yeah, and that's definitely possible. And the Opti vendor actually has some examples of that, where the people running the thing for hurricane areas didn't trust the system, or the system wasn't set to actually pump down, and they took control and pumped down ahead of time. So we'll have our system operators in the public works side.
Yep.
I'm going to be able to view the system, and then our consulting engineer who did the design is also viewing the system. And we're going to be viewing it closely here during the setup and during these first few events. We still owe a review of the system and its performance to our regulators and our partners downstream. So especially in this first couple of years as we get comfortable with it, there's this portion that we got to train the public works workers to see how it works, understand how it works, and gain the trust for how it works. So there's definitely a lot of that in the near future.
Cool. One of the questions you actually generated for me here, and I think it's a good one. If a community was looking to start the planning for a similar project, what advice would you give them?
Yeah, look for others who've done it. I'm willing to take the calls and talk about it from the kind of the public buyer perspective. But as you get comfortable with the technology, you're going to want to start the conversation as early as you possibly can with your downstream parties, with your upstream parties, with the watershed that you're working with, they need to be up to speed with it as well. Because when we ran into this as, this was the first, real big implementation of it, there was, we just kind of got wrapped around the axle in our regulatory process just because of the fear of the unknown and how it works. That risk conversation that I've kind of described here, you've got to start, opening up that wavelength with your partner organizations. And if you're not normally talking about, risks and trade-offs, certainties and uncertainties, I feel like sometimes regulators or the public wants, that 100% certainty from the engineer. This is an area where we got to get comfortable talking about risk. So, partnership and risk conversations is my first point of advice for anyone looking at this.
Yeah. And the fact of the matter is there's a lot of risk out there right now if we don't do anything.
That's right.
So there might be some risk with
always compared to your current condition.
But there's absolutely more risk if you don't do anything at all.
Yeah, and when you're focused, or when you're kind of opening up that area of your mind to a risk conversation as part of a new project, and then you start also looking back at your current system, you can get a lot of uncomfortable feels. So I feel like that's why the partnership and working through this together to say, okay, now as you start to open up your mind to risks and trade-offs, also start to apply the same to your current mode of operation, you might find some obvious things you should be doing.
Right. And, I go back to, as we talk about that risk in our current environment, in our current situation, I go back to the beginning of this conversation where you guys were looking at, you were redoing your stormwater management plan, and, you're running these new models and you're seeing, where the flooding is going to occur in different rain events. And a lot of communities are in that boat right now.
Right.
No pun intended, but hopefully you're in a boat when that happens. But, a lot of communities, I know in Roseville, we were doing that. We were running these models, and for us, a lot of it was at a sub watershed level. And Ryan Johnson, his title is environmental manager, but he is a stormwater nerd.
I know well.
Yeah. And he was running these models, and we would, we come up with these figures showing whether this flooding was occurring or will occur. And in a lot of cases, we were seeing minor flooding. We would see standing water in streets for a period of time or something like that. But then you put in the new precipitation models, you put in the new 100-year storm, and you're just like, whoa. And so you have all of these new figures showing all these new flooding areas in your communities. And I think every community, particularly the first ring communities, but definitely second and third ring communities as well, are seeing those new maps, those new flood prone areas.
Yeah.
And there is risk if we don't do something with that.
Yeah. And maybe that's something that we did that's a little bit new and leading that others could learn from as well. So when we did that 2018 event, as professional staff, we looked at those things and said, we know that this is going to bring a lot of conversation, a lot of interest, and that we're going to be the ones that is going to be asked how to interpret this.
Yep.
But there was never a question of, should we publish this or not?
Right.
And I think sometimes folks, see the fear in their own groups, and then they make a decision, let's not publish this, or let's just put it in a PDF document. We've gone completely the other direction in Edina, and I think it's critical for that community capacity building. We've got a website that's active. What is my flood risk, or Edina flood resources? You can Google it right now and type in your address and see what the models predict for flood exposure for your neighborhood, for your home in general, and that face it and get the community on the pulse was really, we don't think we're brave as staff, but that was our task force basically saying, you need to get this information out to people, because we sat at that table and saw the yawning gap between what we were able to provide and expectations. You got to narrow the gap there. You got to have people's expectations, and people come to that data in their own time. Even if you do direct mail to everybody, someone's going to come and look at that data on a daily basis, and we take the calls, and we have to be ready to talk about it. Yep. And I think that skill set that we've developed between 2018 and 2021, when we were getting into this project, really helped us, have those conversations be on the same pulse and the wavelength of the council and the public. So there's a lot of work that was done there that, got me to this comfort level with the risk conversation that I think could be valuable for a lot of communities.
Yeah. Well, good. Well, that was really interesting. And for the the nerds, the real nerds out there, we are going to put, Ross has provided me with a great deal of information, and I referenced the capstone study, and you've got a presentation on there with Bar Engineering was a consultant on that. And we've got a lot of other data that we'll put up in the show notes for that. So thank you. If there's anything else,
thank you, Mark.
Send it to me, and we'll make sure we'll post that up there. But now as we get towards the close of the show here, one thing I try to do with all of the episodes, don't get it done in all of the episodes, but I want to have that conversation about technology. And clearly this whole episode has been a great conversation about how you have applied, some new technology, or not necessarily new. I mean, a lot of the technology you're using was being used in other applications, right? But really focused new algorithm and a new way of thinking on that. But outside of this, where else have you seen like technology make a really big difference in your operations, or maybe you see something coming down, on the horizon that's going to make a similar impact in a different aspect of public works?
Yeah, so we're looking out at the future. Where do I see the opportunity?
Yeah. Or something that's similar that's made an impact recently.
Yeah, we're seeing a lot of potential for synchronizing our operations and our energy use when it comes to these type of real-time controls and kind of smart infrastructure approaches. You think about like how deep you got to pump for a different well, and the economics of individual wells kind of competing. You might be able to do some stuff with energy management for your own system. Everywhere you have storage, we got a 4 million gallon in-ground reservoir that we need to really switch water through. That's
for your water
for a water supply. There's some potential there. I guess I'm not seeing screaming opportunities, and the cost to turn the crank on some of those really hasn't made sense for us yet. But I think as the cost of implementation and the value becomes more apparent, I see a lot of potential there.
Yeah. And I also think one thing that is a pro and a con for us in the U.S. is our water does not cost very much water. It doesn't cost very much money.
Yep. Yeah, in Minnesota specifically, we've got abundant water resources and an amazing aquifer. So I think you'll see some of the value points popping up in scarce situations first.
Yeah.
So we might not be leaders in some of those areas.
At some point, and certainly in the West Coast is seeing this now, but at some point we're going to get to a point where we do value our water much more, our potable water a lot more, because we're afraid of pumping our aquifers dry or what have you, and then what you're talking about, those technologies will emerge. We'll start applying those technologies to those systems, but right now it just doesn't make sense.
It's got to cost out. It's got to make sense.
Right. So, well, cool. Anything else you wanna mention, or I know let's just touch on this. I know that Edina's been a leader, because I haven't talked about this yet, and I need to have an episode on this at some point, because it's become something that I've been working very closely with at Bolton & Make now, but EV chargers.
Oh yeah.
And so I'm taking a hard left turn here. But I know Edina again has been a leader in putting in EV chargers across your city and that. So maybe just talk a little bit about Edina's program and that. What's your vision? What are your goals for EV chargers in the public realm? But also, how are you helping with the private sector implement, and put in EV chargers?
Yeah, our primary purpose for the EV chargers in Edina is to approve our electric fleet. So it's a part of the carbon reduction strategy. When you don't burn a gallon of gas, but instead take a wind-sourced, kilowatt hour of electricity, you're doing really good work for those carbon goals. So, where we have like liquor stores and operations delivering, we also make them available to the public. We've got several, public chargers, but it's really built off of the decarbonize our fleet strategy. And yeah, when we've got in-house electrical support in Edina and a sustainability manager. So we've got some of the horsepower to really, create the relationships.
What's the in-house electrical support you mentioned?
Yeah, so we've got a master electrician and several other electricians that, do all the power for facilities, for traffic lights, for lift stations. So rather than calling consultants for every one of those, we have someone who knows power and a master electrician in the building. And that gives us the ability to kind of own, operate, and maintain some of our own charging infrastructure. So kind of a key in-house capability there.
And where are you in electrifying your fleet?
The obvious opportunities for us are all the light-duty trucks and all the light-duty passenger vehicles. So we're really getting aggressive in those. We're taking on those things as fast as the market can provide. Right. So a lot of it is, the hatchback, the small cars, plenty of options there. But, light-duty trucks still...
Have you looked at putting any orders in for a Ford Lightning or anything like that?
We got a Ford Lightning right now, or maybe two of them. The police are trying one of those out. We got a Mustang Mach-E on the police side.
Mustang Mach-E.
Yeah, they're nice. And then we got a lot of Bolts and Leafs and others for some of the building inspections, health, engineering inspection vehicles.
But looking out to some of your larger equipment, I know when we had Scott Grayson on, he mentioned Washington, D.C. had recently purchased a couple of electric sweepers. Is that in your guys' vision, or do you guys think you're close to implementing something like that?
Yeah, so the vision is always to include it in the purchase decision. Yeah. And so when the last sweeper came up, we did look at electric options. The 100% or maybe 200% price premium for that electric versus the diesel option just really hasn't been worth it to us yet. But we do see the opportunity in those high use and high load demand vehicles because someday we're going to need to, find green options for those. And unless we got a green fuel or that we can use, electrics in the options.
Yeah. To that point, like, do you guys have a threshold? And maybe it's just a case by case type of situation, but how much more will you pay for a green solution for a vehicle versus, maybe it doesn't necessarily work out with the gas savings, but like what is that premium you would pay for that green solution?
Yeah. So like for the light duty cars and trucks that I was talking about, I think there's no premium to be paid. There might be a premium in terms of capital, but the life cycle over time, it's a several year payback.
Oh, and the maintenance on those too is a lot lower.
Oh yeah, so it's those are no brainers already. I think we're willing to pay a premium. Maybe it's in the 10 to 50% range, but it has a lot to do with the other opportunities that were easy to take at the time. So our sustainability manager has a fund that's always replenished, and we might see other opportunities in the community, and that fund has just been changed so that it can fund, household retrofits or the energy squad visits that get individual people up to speed. There might be some rebates for personal electrical vehicles. So we're trying to take a community profile approach before, going deep on, some of those maybe less fruitful, sweeper or whatever. Some of that just the technology, you just got to wait a little bit.
Cool. Well, exciting. Well, I look forward to seeing all of the things. For those that don't know, for those outside of Minnesota, Edina's we joke a little bit about Edina. My son played hockey. Edina is a perennial powerhouse in hockey. And we call them the cake eaters because, it's a good, prosperous first ring suburb outside of Minneapolis there. But all joking aside, I do look forward to Edina has always been a leader in so many things, and people like Ross continue to help make it so that Edina is leading the public works world and the implementation of a lot of this stuff. So thank you for that. Thanks for teaching us a lot of things, Ross. And look forward to seeing the next thing that Edina works on.
Yeah, so thanks for having me today, Mark.
Yeah, thank you. And one last thing before we go, if you have enjoyed this episode and the podcast in general, we ask that you help us spread the word. If you're on LinkedIn, comment. If you're on YouTube, watch the video. Yes, we're on video. And comment. Make a comment on there or share the YouTube video. And retweet one of our posts. Share it on Instagram. Help us spread the word of this podcast. But better yet, tell all your colleagues about the podcast. Thank you.